Hello everyone, welcome to the new video of physics solutions. This is solution for physics unit 1 GCE June 2017 paper. So let's start the solution. Question number 1. Quantities are either vector or scalar. Which row of table correctly states vector and scalar? So you need to choose correct row corresponding to the vector and the scalar. So first choice is A, force, which is in a correct column. Force is a vector. But if you see displacement, displacement is not a scalar, it is a vector quantity. In column B, time is in the vector column, which is wrong choice. Mass is also a wrong choice. And if you see the displacement, which is a vector, and the mass, it is a scalar. So your option is B. Question number 2. A bubble moves upward through a fluid at a steady speed. Steady speed means constant speed. So speed is not changing. That means net force should be 0. Net force equal to 0. So the bubble are shown all the forces. Which equation correctly describe the force acting on the bubble? That means we must need to find that we must have a resultant force 0, and drag plus upthrust is equal to weight. Of course, this is not the correct relation. And weight and upthrust, of course, weight and upthrust are acting in upward direction, so we cannot add these two. Drag plus weight minus upthrust, yes, it is, because drag and weight are in the same direction, so we can add and subtract upthrust, and their resultant is 0, so option is C. Question number 3. A car is moving at a constant velocity of 15 meters per second. The driver applies a brake uh, and the car decelerates to rest at a constant rate. The velocity time graph for the final 6 seconds of the car's journey is shown. Okay, this is the graph for final 6 seconds. The distance the car travels while braking is, okay, that means we need to find the distance while braking. This is important, while braking. And remember, distance mean, if we have a graph of velocity time, distance mean area under the graph. Area under graph. But we need to find the area while braking. So from this point, this is the point where the brakes are applied, and this is the point when the car is stopped. So you need to find the area under this triangle. Remember, don't find the area of the whole region just for that triangle. That means if you do your calculation finding the area, so half of base into height, base is 5 second, height is 15. So if you calculate this, the answer will be 37.5, which is when you round it off, the option is A. Select the row from the table that correctly describe the SI prefixes. SI prefixes, this is pico. Pico means 10 to the power minus 12, and giga means 10 to the power 9. So 10 to the power minus 12, question 4, yes, option B, 10 to the power minus 12, and 10, so option is B. Question number 5. Two students P and Q of equal mass climb to the top of the mountain. They both start their climb from the same vertical height. Student P takes 2 hours to climb a shorter, steeper route. Yes, okay, fine. This is the path of the student P, and the Q takes 3 hours to climb longer and steeper route. Okay, this is Q. Fine. Which row of the table correctly describe the gain in potential energy and the power developed by student P compared to Newton cube. Okay, so regarding the gravitational potential energy, if you see that both are reaching at the same height, and gravitational potential energy, because uh, is mgh, and mass of both students are same, that means their potential energy only depends on height. But for both students, they are reaching at the same height, so their gp should be same. That means option A and option B immediately gone. We cannot have the option A and option B. But option C and D, they are saying the gravitational potential energy are same for both. Okay. Next thing is, we need to find the power developed, and you can see that as P is going up the hill along the steeper path. Steeper mean, if you see the inclined plane, the force acting on the moving object is the component of the weight, which is W sine theta, and because of the steeper angle, this force acting on P will be greater. So force is greater, that means power generated by P is greater. So the option is C. That means they have the same potential energy, and the power developed by P is more than the Q. Question number 6. A car pulls a caravan at a slow but increasing velocity along a horizontal road. Okay, direction of the motion. The four forces acting on the car are W and reaction R on the car, and tension T and the tow bar, and the friction between the car tires and the road. Which of the following could be free body diagram for the car? Okay, we need to find the free body diagram for the car. If you see, this is the car, so weight is acting down, contact force is upward, and tension in the tow bar is in that direction, which is T, and engine force in that direction. So we have a four forces in this, all the four options. That means if you see the diagram, it is moving direction of motion, so engine force should be rightward. So immediately we cannot have option of A and B. We need to choose which one is C and D. If you see increasing velocity, that means we have acceleration in forward direction. That means yes, engine force is greater than F, must be greater than the tension. So we must have option D for question number 6. Question 7. A ball is dropped, bounces once at time t by 2, and is then caught at time t. Okay. The velocity time graph for the motion of the ball is shown. This is velocity time graph. Okay, this is the time where the ball is bounced. Assuming that the initial displacement of the ball is 0, which is the correct displacement time graph for the motion of the ball. If you remember in your theory, the bouncing ball, if you drop ball from some height and your ball is coming down, so generally we say that the displacement time graph or height time graph is starting from maximum height and comes down. So as they are saying, consider the initial displacement of the ball is 0. So if you take this point as a 0 height, as a 0 displacement, okay, 0 displacement, that means the ball will come down and then moves up. So it is clearly, you can see that the graph of position and time graph is coming down from origin and going up again. So your option is B. Question number 8. The flow of water in a pipe is turbulent. Which statement correctly describe the turbulent flow? It's all about the definition of turbulent flow, that means abrupt change in direction and the velocity. So if you can find these two wording, abrupt change, sudden change in the direction, and the velocity, so speed and direction point remain constant, not at all. Layer parallel, no, it's all about streamline. The layer do not mix, it's again streamline. There are sudden change in speed and the direction. So your option is D. A person stands on some bathroom scale in a stationary lift. The lift begins to move upward with a constant acceleration. The reading on the scale will, remember, it's all about the lift motion. So as lift start moving upward, initially you have acceleration, and then after moving a little bit, the lift keeps moving with a constant velocity between the two floor, and then when your floor is about to reach, the lift decelerate. So you have acceleration and you have deceleration. So acceleration from the ground floor cause increase in the weight, but as in between your lift is not accelerating, so your weight remains constant. That means the reading on the scale will increase, but then remains a constant. Yes, of course. Initially, the weight, the reading will show increase in the weight, but remains constant. The option is A. Question number 10. On a guitar, two strings are tightened to the same tension. The diameter of one string is double the diameter of the other. The stress in the thicker string is sigma. What is the stress in the thinner wire? Okay, so if you see the stress, sigma is equal to force upon area, as both wire have a same tension. That means force is constant. So you can say sigma is proportional to 1 upon A, or sigma is inversely proportional to the area. And remember, area is pi d by 2 whole square. So if you see, if you double the diameter of your thinner wire, that means area would be 4 times. So in fact, your area would be equal to 1 upon 4. That means sigma would be 4 times. If this 4 goes up, it will multiply with the 1. So the option is 4 sigma. Okay, let's see the next question. Question number 11. A student carried out an experiment to determine the spring constant of a spring. The diagram shows the arrangement of equipment used. This is the equipment. Each time a slotted mass was added to the hanger, the position of the pointer was recorded and the extension of the spring calculated. Describe how the students could use graphical method to determine the spring constant of the spring. So what is happening in this experiment, you are measuring two things. Number one, you are measuring mass that you are loading one by one on the hanger, and this mass can be converted into weight, okay, which is in Newton, and you can also call it as a load that you are giving. And against the load, you are calculating extension for different load. So meaning you can plot a graph between load and extension. Here I am taking load as independent variable and extension is dependent variable, but if you wish, you can say that extension is independent and load is dependent. It's fine, but what you have when you plot the graph, you would have a straight line, and from the straight line you can calculate the gradient. It depends on which graph you are using, and according to the graph, whether load extension or extension load, the gradient is showing the stiffness or the spring constant. So that you need to talk about or write about the graph between load and extension line and the calculating the gradient. So you can write the point like this. After the recording various reading of extension for a different load or weight, a student is going to plot a graph between the load and in Newton and extension, and then find the gradient and will give the spring constant. And for part B, two ways in which this method contributes to an accurate value for the spring constant. Yes, it is a good experiment because we are using pointer, if you see here, and the pointer will reduce the parallax error. And of course, we are using graphical methods, so we can take a number of reading and we can remove any anomalous result in order to reduce the error in our result. So this is how you write for B. Okay, let's see question number 12. A mobile phone falls to the floor. The glass screen shattered while the aluminum frame remains intact. Explain why this happened in terms of properties of glass and the aluminum. So for glass, you know that glass is brittle. Glass is brittle. Brittle. That means it will break or shatter with applying on the force. While aluminum, you can say aluminum is a strong or aluminum is elastic, will not break, or aluminum will return to its original position after impact. Or you can also include aluminum is a tough material, so absorb a lot of energy during impact. So these kinds of stuff you can write here. So it's not a difficult question. So that's how you write. So glass is brittle material that breaks with a little or no plastic deformation. Aluminum is tough and can absorb energy during impact, and it is also elastic. So will return after removing the force or after impact. Question number 13. A spring is attached to a wall. A constant force of 15 Newton pushes a block of mass 0.4 kg along a friction-like surface, compressing the spring of 0.05 as shown, that's 15 Newton, and compressing the spring 0.05 meter. A student suggests that the work done on the block is delta W 15 Newton times 0.05. Explain why this suggestion is not correct. Yes, the work done cannot be just force time extension because the force throughout the displacement is a constant force, but inside the spring, as it is compressed, this object experiences an opposing force from the spring, and this opposing force reduce the amount of 15 Newton. That means if you see the situation, you have a less resultant than 15 Newton, so work must be less than the suggested one. So you can say that the work done is less than the suggested one. Sorry, it's not on. Suggested should be suggested one. Because of an opposing force of a spring on the block, that means resultant force will be less than 15 Newton. So this is part A. You can say. What about part B? When the spring is compressed by 0.06 meter, the tension in the spring is 18 Newton. The mass is held in this position and then released. The block now moves along the friction-like surface, losing contact with the spring once the spring has reached its original length. Calculate the velocity of the block after it loses contact with the spring. It's a 3-mark question. Okay, let's see what is given. Okay, so it's all about when the spring is compressed, then elastic potential energy is stored. So we have elastic potential energy stored when it is compressed, and when it is released, this elastic potential energy converts into kinetic energy. So you can write like half of Fx, which is elastic potential energy, must be equal to half mv square, and half you can cancel. So F is 18 Newton, X is 0.06, yes, is equal to mass of the object, which is 0.4. So mass is 0.4 times v square. You rearrange and make v as a subject, so you have a velocity is equal to 1.64 or 1.6 meter second inverse. Okay, let's see the next question, which is magma consists of a molten rock and gas, and is found beneath the surface of the earth. During a volcanic eruption, the magma rises to the surface and pours through an opening in the earth's crust. As the magma rises, the pressure decreases, the bubbles of the gas expands and rises through the magma. Explain why the bubble rises faster through the magma as they start to expand. Expansion of the bubble cause increase in the speed, or you can say the velocity. So it's all about Archimedes' principle. If you remember, when an object is immersed in a fluid, it displaces fluid around, then experience an upthrust, which is equal to the weight of the fluid displaced. So increasing the volume, expansion means increasing the volume. If the volume is increased, that means more magma or more fluid is displaced. That means more weight of the fluid. That means upthrust is increased. If upthrust is increased, that more resultant force in upward direction. The resultant force is increased, so the speed or the velocity is increased. So that's how you can write all these points. So you can read, as the bubble expands, volume is increasing, amount of fluid displaced is also increased, therefore upthrust increase, create a net resultant force increase upward direction. So due to the increase in net upward force, the speed is increased. Okay, part B, the table shows 3 types of magma: basaltic, andesitic, and rhyolitic. Okay, these are types of magma: viscosity low, medium, high. Types of magma explain through which magma type the bubble will rise with the greatest velocity. Greatest velocity means less drag. Less drag and drag depends on the viscosity. So clearly you can see that basaltic has lower viscosity than all if you compare. So low viscosity means less drag. Less drag means greater the velocity. So you can write the viscosity of basaltic magma is lowest, so the drag is less, so the velocity is more. The magma cools, part C, the magma cools as it reaches the surface of the earth. State how cooling affect the magma. course, cooling means decrease the temperature. So temperature is decreased. Temperature is decreased. Temperature decrease. So viscosity increase. Increase mean of viscosity. You can leave it here, or you wish you can say that flow rate. Flow rate of flow of magma is 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 also decreased. Okay, that's it for, let's see if there is another part now. This is the last part for question number 14. So thank you for watching. We will solve the rest of the question in the next video. Thank you very much. See you.